So we have that f of 1 equals 3, and that the integral from 1 to 4 of f prime at x dx equals 12. And we want to find the value of f of 4. So we know that the integral from 1 to 4 of f prime of x is the same thing as the antiderivative of f prime evaluated at the two endpoints 1 and 4. But the antiderivative of f prime is just f, because f prime is the derivative of f. So this will just be f of 4 minus f of 1. That's just fundamental theorem of calculus. And we also know that this is equal to 12. So we have an equation now that says 12 equals f of 4 minus f of 1. We know the value of f of 1. We know that it's 3. So you have 12 equals f of 4 minus 3. So f of 4 equals 15. So the answer would be D. And then hopefully that made sense. Now I'll go on to the second question. Okay, so the horizontal asymptotes of a function are just whatever the function approaches as x approaches plus or minus infinity. So first, we'll take the limit as x approaches infinity of the function. So we want to take the limit as x goes to infinity of f of x, which is e to the x over e to the x plus x. So here, e to the infinity, that goes to infinity. And e to the infinity plus infinity also goes to infinity. So we have an infinity over infinity indeterminate form. So you could do this a multitude of ways. Like you could just eyeball it and see what it goes toward, or you could do L'Hopital's. I guess I'll just do L'Hopital since that's what we were formally taught. But this will equal the limit as x goes to infinity of e to the x, which is the derivative of e to the x. And then the derivative of the bottom is e to the x plus 1. And I could use L'Hopital's rule again. But the thing is, as x approaches infinity and it gets really large, this 1 is pretty much just going to vanish. So this is effectively the limit as x goes to infinity of e to the x over e to the x, which is actually what you'd find if you would do L'Hopital's rule again. But this is just 1. So because e to the x over e to the x is just 1. So this limit approaches 1. And what I said here about like how 1 vanishes as it goes to infinity, you could have applied that rule up here with the e to the x plus x as well, because x grows a lot slower than e to the x does. So you could have just noticed that and saw that this is just effectively the limit as x approaches infinity of e to the x over e to the x, and saw that it's just 1. So that's the first horizontal asymptote. Now we will check the second one, which is as x goes to negative infinity of e to the x over e to the x plus x. So e to the negative infinity, that will go towards 0. Same thing on the bottom, that's 0 minus infinity. Since x obviously goes to negative infinity, as x goes to negative infinity. And then e to the x, just like the numerator, goes towards 0 as x goes to negative infinity. So this is just 0 over negative infinity, which is just 0. Because if you have 0 divided by a really large number, that's still going to be 0. Because this isn't an indeterminate form, because anything divided by infinity other than infinity will be 0. So the two horizontal asymptotes are 1 and 0. And now I'll do the next one. Okay, so it says the graph of a function g is shown. A, verify that G satisfies the hypotheses of the mean value theorem on the interval 0 to 8. Estimate the values of C that satisfied the conclusion of the mean value theorem on the interval 0 to 8. And C, estimate the values of C that satisfied the conclusion of the mean value theorem on the interval 2 to 6. So the mean value theorem only works when the interval you're going over is continuous and differentiable. And you can just prove this by looking at it. You can see that there's no cusps, there's no asymptotes, there's nothing that'll make neither the function or the derivative discontinuous. So it's continuous and differentiable on the interval 0 to 8. So therefore, the mean value theorem will also apply. So that's A done. Now B, I'm just going to try to draw a secant from one end to the other. This is going to be kind of tough, but I mean, I guess I could use the line tool. Kind of hard to get exact, but that's like a rough estimate. It should connect over here, but it's kind of finicky. But that's like a very rough estimate. So now we can just, oh, it actually just snapped on. Nice. Now we can just like see which points have tangents that are parallel to that secant line, because what the mean value theorem states is that if you have a closed interval from A to B that's continuous and differentiable, like our example, the secant line, or the average slope, there will be some tangents in between that interval where those tangents are parallel to that secant. So there will be some value C such that its derivative is equal to the average slope. So I can just see, just by eyeing it, that like it'll be somewhere up here. That'll be one, and then somewhere down here. So to me, that looks like x equals 2. And then that one's kind of tough. Like, this is giving me flashbacks to that one question on the other child's math that I did not like. But this is around 1, 2, 3, 4, 5, 6. So I would say 6.5. You could say 6, but 6 looks more like 0. So yeah, I would say 2 and 6.5. So hopefully that's right. And then C, estimate the values of C that satisfy the conclusion of the mean value theorem on the interval 2 to 6. So the mean value theorem will still apply here, because obviously if it's continuous and differentiable on 0, 8, then it's going to be continuous and differentiable on 2 to 6. So we have, here, I'll just copy this so we're not like going on the same picture, but we have x equals 2 right here, and then 3, 4, 5, 6 right here. And we want to draw a secant between them. So I'll do the line again. Once again, it's not like exact, but yeah, that's a pretty good estimate actually. So I can see this V1 and right here also. Yeah, down here. So that up here, that looks like x equals 3.5 to me. And then down here, that looks like x equals 5.5. So for B, we had 2 and 6.5, and for C, we had 3.5 and 5.5. So I don't see any new questions in the chat, so just keep them coming. Okay, another one just popped in. Oh yeah, by the way, for this question we just did, this might be wrong because like it was like the same thing with the question on child's math. There were a lot of different answers, and it's kind of hard to see, so this might be wrong, but it should be around the same area. Okay, so this question says, let f of x equal 1/4 x to the power 4 plus 1/3 x to the power of 3 plus x minus 2. Find the intervals, if any, where f is concave up. Okay, so to check for concavity, we need to find the second derivative. So obviously to do that, we need to find the first derivative first. So we are going to take the derivative. So f prime at x equals, the power rule, you take the power down. So that's 4 times 1/4, which is just 1. So this is just x cubed plus 1/3 x cubed. That's just x squared. Then plus x, that's just 1. And then the derivative of a constant, in this case -2, is just 0. So that's our first derivative. And then our second derivative, we're going to take the derivative again. So the derivative of x cubed is 3x squared plus 2x, because that's the derivative of x squared. And then same deal with this one. Derivative of a constant, in this case it's 1, is just 0. So now we want to check where it's concave up, and that's when the second derivative is positive. So first we want to check if there's any critical points for the second derivative, so POIs, points of inflection. So we want to set that equal to 0. And then I see I can factor out an x. So we have 3x plus 2. And so this means that x equals 0 or x equals -2/3. So I'll do a number line now where we have -2/3 and we have 0. And so over here, this is -infinity to -2/3. This is -2/3 to 0. And this is 0 to infinity. And now we'll check each factor. So do it over here. We know that the second derivative is this, x times 3x plus 2. So we can look at each factor. We can look at x, and we can look at 3x plus 2, and then we can look at it as a whole. So this is kind of ugly looking, but it should do the job. So here, like, if you want, you can just put in a value that's less than -2/3 and then just check. So if I put in a -1, I can see that x is going to be negative. And then 3x plus 2, that's -3 plus 2, so that's also going to be negative. And a negative times a negative is a positive. So the entire second derivative will be positive there. And then in between -2/3 and 0, I can see that x is going to be negative. Once again, you can just put in a number, but I can see that x is going to be negative, and 3x plus 2 should be positive. And then, so a negative times a positive is a negative. And then in between 0 and infinity, both of them will be positive. So we can say that it's concave up wherever there's wherever it's positive. So right there and there, which is -infinity to -2/3 and 0 to infinity. All right. There's a lot more questions now, so I'll go to the next one. Okay, so a deer sees a tasty bush of berries across a 10-meter wide river, but 30 meters downstream. He better hurry to get these berries before some other deer sees them. He could swim across the river, then run along the shore to the berries, swim directly to the berries, or swim to a point partway along and run the rest of the way along the shore. If the deer swims at 4 meters per second and runs on land at 10 meters per second, which point on the shore will land will the landing point minimize the time to get to the berries? Okay, so we know that first speed or velocity is just distance over time. So time is distance over speed. So we're going to be using this relationship for this question. And based on our diagram, we can see that right here, that's the distance in the water. And then here, that's the distance on land. And we know that that's 10 meters. And then we can call the distance on land x. And so that means that this distance right here, that is 30 minus x, since that entire length is 30 meters. And so this distance that I have in green, we can just use Pythagorean theorem for that. So we know that one of the side lengths is 10, so 10 squared plus 30 minus x squared. That's equal to, we can call this d1 for distance 1. And then the other one I'll just call x, because we don't really need to call it d2, because we just have a variable for it already. By the way, if you guys see me make a mistake at any point, just let me know. But we want to solve for d1 here. So that's obviously just going to be the square root. So d1 equals square root of 10 squared, which is 100, plus 30 minus x squared. So we can evaluate this. So 30 squared, that's 900. 900. And then this will be minus 60x plus x squared. And so 100 plus 900 is 1,000. Then minus 60x plus x squared. So the total time, let's say time total, is going to be equal to the first distance times the first velocity, which is the velocity in the water, plus the second distance, which is just x in this case, x over its velocity on land. So we just found this relation that the first distance is square root of 1,000 minus 60x plus x squared. And then the deer's speed in water, it says swims at 4 meters per second and runs at 10 meters per second. So this should be divided by 4. And by the way, if you didn't get why like I added these two together there, that's just because those are the individual times. Like d1 over v1 is the time in the water, and then x over v2 is the time on land. So the total time would just be the sum of the individual times. So we have square root of 1,000 minus 60x plus x squared over 4, 4 meters per second, and then x over 10, because 10 is the speed on land. Now, I'm just going to call this t of x, just so I can write it as a function of x. But now we can take the derivative, because we want to see at which point on the land will be the most optimal point to land. So t prime of x, this is just a constant multiple. And then we know by the power or the chain rule, this will just be 1 over 2 root 1,000 minus 60x plus x squared. And if you don't get why I did that, it's just because if we were to write this out, this is just 1,000 minus 60x plus x squared, all that to the 1/2. So just by the chain rule, I just brought the power in front, and then now and I just subtracted by 2 and then kept the inside. So now I have to, by the chain rule, have to multiply by the inside, which is just negative 60 plus 2x. And then the derivative of x over 10 is just 1/10. Oh, never mind, that should not be in that bracket. That should just be 1/10. Now, we can set this equal to 0, because we want to find one of the critical points. And I'll just write this like 60 plus 2x over 8, since 4 times 2 is 8, square root of 1,000 minus 60x plus x squared plus 1/10. Now we can move this 1/10 over to the other side. So this will be negative 1/10. I'm actually going to write this as 2x minus 60 over 8 square root of 1,000 minus 60x plus x squared. Now, I can cross multiply, so we have negative 8 times the square root of 1,000 minus 60x plus x squared equals 10 times 2x minus 60. Now this, I'll just write this on the side. That's just 20x minus 600. And then I'll square both sides now. So 8 squared, or negative 8 squared, is just 64. And then this whole thing is just the inside part, since we're squaring a square root. That's equal to 20x minus 600 squared. So 20x minus 600 squared, so 20x squared, that's 400x squared, minus 2 times 20 times 600. So that's minus 24,000. And then minus or plus 600 squared. And 600 squared is just 360,000. So these are some pretty big numbers, but they should work out in the end. This side is just 64,000. So we have 64,000 minus 64 times 60, which is 3840x plus 64x squared. That's equal to the right-hand side, which is 400x squared minus, this is meant to be an x there, minus 24,000x plus 360,000. Now I'll just move everything to one side. So I'm going to move the left side to the right-hand side. So we're going to have 0 equals 400 minus 64, which is 336x squared. We have minus 24,000 plus 3,840, which is just negative 20,160x. And then we have 360,000 minus 64,000, which is just 296,000. So now we can solve for x. And I could reduce everything and like do a whole bunch of other stuff, but I'm just going to put this into our calculator just so I don't have to worry about that. So A is 336, B is negative 20,160, and C is negative 296,000. So, I think I may have made a mistake. Because it says I'm getting 72 and negative 12. And 72 is not within the domain, and neither is negative 12. So, oh yeah, thank you. Thank you, it's plus 296,000. So let me try that again, sorry about that. 336, negative 20,160, and then positive 296,000. So now I'm getting x equals 34.36, or x equals 25.6. So we can see in the question that this length, that is 30 meters. So we know that this is impossible because we can't have it out of our domain, but this is possible because it's less than 30. So we know that the deer should land 25.6 meters away from the endpoint. So that's our answer. I hope that's right. That was a really long question, so it would have been pretty easy to make a mistake like what I just made with the negative 296,000. But I'll move on to the next question now. So, evaluate the following integral. The integral from 0 to 1 of 3x squared over the fourth root of 16 minus 15x cubed. So, the first thing I see is that we have an x cubed in the denominator and an x squared in the numerator. And the derivative of x cubed is 3x squared. And so if I set u, like if I did a u substitution and I set u equal to the denominator, the derivative would be something of the form a constant with x squared. And then that would turn into our du, which would go at the end of the integral. And then we could just solve it in terms of u. So I'm going to rewrite the integral right here. 0 to 1 of 3x squared over the fourth root of 16 minus 15x cubed integrated with respect to x. So now I'm going to say u equals 15 minus 16 minus 15x cubed. And something you can see is that if I made u equal to negative 15x cubed, it would do the exact same thing. My derivative would be the exact same because the derivative of 16 is just 0. But with u substitutions, you want to take as much as you can, and you'll see why. Because you want to make sure that the entire ugly part of the denominator gets eliminated. So now we can take the derivative, and we see that du equals negative 45x squared dx. And now if we isolate for dx, we see that dx equals negative du over 45x squared. So now we can sub this in, and you also want to change the bounds of integration. So when x is 0, u equals 16, since 15 times 0 cubed is just 0, so 16 minus that is going to be 16. And then when x equals 1, u equals 16 minus 15 times 1 cubed, which is just 1, because 15 times 1 cubed is 15, so 16 minus that is just 1. So now we have different bounds of integration, and we can bring this down here, and then this is equal to the integral from when x equals 0, u equals 16, and when x equals 1, u also equals 1. So the integral from 16 to 1 of 3x squared, and this will cancel, as you can see like in a second, of the fourth root of u, because that's the entire denominator, u, and then dx is negative du over 45x squared. And so now these x squareds cancel, and what I'm also going to do is I'm going to change the bounds of integration. So they're going from 1 to 16 instead of 16 to 1, because that's just proper form. So we have 1 to 16, and when you do that, you need to put a negative sign outside. But right here we have a negative sign. So I'm just going to use that negative sign to flip the bounds instead of having to write another one outside. And then we can pull the constants out, and the constants are 3 and 45. And 3 divided by 45 is just 1/15. So we have 1/15 of 1 over u to the 1/4 du, which is just 1 over 1/15 times the integral from 1 to 16 of u to the negative 1/4 integrated with respect to u. And then if we integrate this, we get that. So we just need to add 1 to the power. So 1 is 4/4. So this should be u to the 5/4. And then we want to divide by that. So dividing by 5/4 is the same as multiplying by 4/5. And then this is evaluated from 1 to 16. So we have 1 over 15 of, I'm also going to factor out 4 over 5. So this will just become 4 over 75, because 15 times 5 is 75, and 4 times 1 is 4. And this will be 16 to the power of 5/4, minus 1 to the power of 5/4. So this is 4 over 75. If we take the fourth root of 16, we just get 2. This is 2 to the power of 5 minus 1, since 1 to any power is 1. And then 4 over 75 of 2 to the power of 5, which is 32, minus 1, which is 31. And then 4 times 31 is 104, I believe. Or 124, sorry. I don't know how I made that mistake, but 124 over 75. And so that should be our final answer. So I'm sure McLean or Childs or whoever you have for math would have mentioned this in the lecture. But as you can see, when we're done integrating, like right here, we can sub u back in as this. And then we can just integrate from 0 to 1, which are our original bounds in terms of x. The thing is, that would make things a lot more complicated, and it's just easier to keep it as u. And that's always going to be the case. So now I'll move on to the next question. I just realized, looking at the possible answers, my answer is not an option. So, oh, it's because it can be reduced more. Never mind. Okay, so I must have made a mistake. I'll just quickly look over it. So, u equals 16 minus 15x cubed. So du equals negative 45x squared dx. By the way, if anyone sees a mistake, just let me know. And then, so dx equals negative du over 45x squared. When x equals 0, u equals 16, that's right. Then when x equals 1, u equals 16 minus 15, that's also right, so it's 1. Oh, right, yeah, sorry. For some reason I was thinking that it said 1/4, but it's actually negative 1/4, so negative 1/4 plus 4/4 is going to be 3/4. Thank you for catching that. So that should be 3/4, and then you divide by 4/3. And so we should be good now. This is 4 over 45, and then this is 16. This is 3/4, and then 1 power of 3/4. And then the 4/3 of 16 is still 2. This is 2 cubed. This is 4 over 45. And then 2 cubed is 8, minus 1 is 7. So 7 times 4 is 28. So it's 28 over 45, which hopefully is an answer. Yep. So it should be A. Okay, cool. Now I'll move on to the next question. Okay, so here's the next question. It says, let big f of x equal the integral from 1 to x of f of t dt, where f of t equals the integral from 1 to t cubed of the square root of 1 plus u over u du. Find big F double prime of 2. So I just saw a question said, also I think you accidentally flipped the derivative. It should be from 16 to 1, right? So that is a good point. It should be from 16 to 1, but I have it as 16 to 1 right here. But if you remember the rule, I'll write this on the side. If you have the integral from b to a of f of x dx, this is the same thing as the negative integral from a to b of f of x dx. And I could have put a negative out front right here. But the thing is, I had a negative right here. So if I pull that negative outside, it would have canceled with this negative anyway. So it becomes 1 to 16, and it's positive out front because I just used this negative sign. So hopefully that makes sense. Yeah, no problem. And then I'll move on to the next question now. So we want to find the second derivative of big F at x equals 2. So we have f of x equals the integral from 1 to x of f of t integrated with respect to t. And now, just by the fundamental theorem of calculus, f prime of x is just going to be, big F prime of x is going to be f of x. And we know that f of t is the integral from 1 to t cubed of square root of 1 plus u over u. And that the variable t right here, that can be any variable. So we can say that f of x equals the integral from 1 to x cubed of the square root of 1 plus u over u du. So now, the second derivative of big F is going to be the first derivative of small f, which is the derivative of the integral from 1 to x cubed of the square root of 1 plus u over u integrated with respect to u. And this would be completely fine if this was an x. We can just do the same thing we did with big F. But the thing is, this is not an x. That's an x cubed. So we have to do the chain rule. So usually, if this was an x, this would just turn into square root of 1 plus x over x. But like I said, we have an x cubed, so we need to do something different. So we're going to keep the function as we would normally keep. So that's square root of 1 plus x over x. But we have to multiply by the derivative of the bound. So that's the derivative of x cubed, which is 3x squared. And I can see that one of these x's cancels, and then we get 3x squared of 1 plus x. And then we want to find that x equals 2. So f double prime of 2 equals 3 times 2 times the square root of 1 plus 2 equals 6 root 3. I messed up again. I'm so sorry, guys. Oh, you're right. Sorry. So that should be x cubed. So 2 cubed is 8. So that should be the square root of 9, which is 3. And then 6 times 3 is 18. And that's still not an answer. Oh yeah, sorry. Sorry guys, I'm messing up hard right now. So that's over x squared, and then now this entire x cubed will cancel with 2 of those x's, and then you'll just be left with you'd be left with 3 times the square root of 1 plus x cubed over x, and then that's 3 times 1 plus 8 over 2, which is just 3. I don't know what's going on right now. Oh yeah, sorry about that. This question's not treating me well, but yeah, not over 2. Thank you guys. Okay, now I'll go on to the next question. Hopefully I don't mess up as hard on this one. So we have the limit. Someone said, could you go over the last question quickly, please? So I'm assuming you're referring to the question we just did. So basically we were given that big F of x equals the integral from 1 to x of f of t integrated with respect to t. And by the fundamental theorem of calculus, if you take the derivative of an integral where you have the integral from 1 to x, then that'll just become the function inside evaluated at x. So the derivative of big F of x is just f of x by the fundamental theorem of calculus. And we know that f of x equals this whole thing, which is the integral from 1 to x cubed of 1 plus u over u integrated with respect to u. And then so the derivative of that, we can use the fundamental theorem of calculus again. But the thing is, we have an x cubed in the upper bound. So we can't just do it exactly what we did before. We put the x cubed in, like we do right here. We put that in as u, and then same thing down here. But we have to multiply by the derivative of that, which is 3x squared. And then these x squareds cancel with two of the x squareds, or one of the x squareds in the denominator, leaving just x to the first power right there. So we have 3 times the square root of 1 plus x cubed over x, and we want to find that at x equals 2, so that's 3 times the square root of 1 plus x cubed, and x cubed is just 2 cubed, which is 8, so 1 plus 8 is 9, square root of 9 is 3, 3 times 3 is 9, and then that's just all divided by 2, so it's 9 halves. So that should be A. No problem. And then, so for 44, we want to find the limit as x goes to infinity of the square root of x times e to the power of negative x over 2. So if we just plugged in infinity, this would equal infinity times e to the negative infinity, which is 0. So this is an example of an infinity times 0 indeterminate form. So to fix this, we can divide by the reciprocal of one of the factors, and it'll become either an infinity over infinity, or a 1 or a 0 over 0 indeterminate form, which we can use L'Hopital's rule on. So I'm gonna flip the I'm gonna put e to the negative x over 2 in the denominator, because that's just gonna become e to the x over 2 when you put it in the denominator. So this is just the limit as x goes to infinity of square root of x over e to the x over 2. And then so this is going to go towards infinity over infinity, since e to the infinity is just infinity. And then we can take the derivative now of both the top and the bottom. Sorry, my pen is kind of acting weirder now. It's like it's not writing what I'm writing, but I'll try my best. So this is going to be the limit as x goes to infinity of the derivative of the top, which is 1 over 2 root x, over the derivative of the bottom, which is e to the x over 2 times the derivative of the exponent, which is just 1/2. And then now we can simplify stuff. We can bring some of the stuff in the denominator up to the numerator. So the limit as x goes to infinity of we can bring this up and flip it, so that'll just become 2 over 2 root x, and then we can bring the e to the x over 2 up as well. So it should be that. Just want to make sure. Yeah. And then these 2's will cancel. And now we have the limit as x goes to infinity of 1 over square root of x e to the x over 2. This denominator is going to blow up to infinity. So we have 1 over infinity, which is just 0. I'm going to try to fix my pen in the meantime while we're waiting for the next question. But yeah, it should be 0. No problem. Now I'll go to the next question. Okay. Okay, so it says the graph of f is given to the right. Let g of x equal the integral from -3 to x of f of t dt. So part A says to find g of 3. So now that g of x equals the integral from -3 to x of f of t. So g of 3 will be the integral from -3 to 3 of f of t dt. And that's just the area between -3 and 3 of the graph. So I can see that we have 3 or 4 different areas. So we have this area, this area, this area, and this area. So I'm going to call this A1, that A2, that's A3, and then that is A4. So this will be A1 plus A2 plus A3 plus A4. And since A1's below the x-axis, technically we can say that this is negative A1. This is negative, and then this is a triangle, so it's base times height divided by 2. So it's -1/2 times 1, since that's the base and the height is 1. So -1/2 times 1 times 1 of A2, which is, it's the exact same triangle, but just above the x-axis. So these actually cancel. And then plus A3. And A3 is just a rectangle with base 4 and height 1. So it's 4 times 1. And then A4 is a semicircle with radius 2. So this will be pi times 2 squared. And since it's half a circle, you divide by 2. So this should be 4 plus 2 pi. So yeah, that should be the answer. And then we have 3 more parts. B, want to find g prime of 1. So like the last question, or the 2 questions ago, fundamental theorem of calculus, the derivative of the integral will just be the function inside. And that's because we have an x as the bound and not a function of x where it's not just x. So g prime of x is just f of x. And so g prime of 1 is just going to be f of 1. If we look on our graph, f of 1, that is just right here. So that's 3. So this is equal to 3. Now C, g double prime of -2. So if g prime is f, then g double prime will be f prime. That's f prime of -2. And f prime at -2 is just a slope at -2. And so that's right here. And the slope of that is just, it's just 1. You can like do that yourself by doing rise over run. It goes up 1 and it goes over 1. So it's just 1. So that's 1. And then D, on what interval is G decreasing? So we know that G prime of x is equal to f of x from part B. And G is decreasing when the first derivative of G is negative. And we know that the first derivative of G is f. So when f is negative, G prime will be negative. So we want to find when f is negative. And that is, I know this graph's kind of crowded, but that's just right here. That's the only time it's negative. So it should just be between -3 and -2. So yeah. Now move on to the next question. Okay, so explain D again. Yeah, sure. So we know that G will be decreasing when G prime, aka the derivative of G, is negative, because when the slope is negative, that is obviously decreasing. So it'll be decreasing when G prime is negative, but we also know from part B, from the fundamental theorem of calculus, that G prime is just F. And I'll clear up the graph. So when we want to find when G is decreasing, we just said that that's when F is negative, and F is negative only right here. Everywhere else it's positive, and that is in between -3 and -2 right there. So that's why it's -3 and -2. That makes sense? No problem. And now I'll go on to the next question. So we have a similar case. We're also going to use fundamental theorem of calculus here, but it's a little bit different. But we have let f of x, big F of x, equal the integral from x to x squared of the square root of 1 plus t cubed dt, and we want to find f prime of 4. So we can't just go about this like any other fundamental theorem of calculus problem, where just the derivative of big F will be the inside evaluated at x. That's not true, because we have certain functions of x that aren't just x. This one's x, so if that one was alone, we would be able to use fundamental theorem of calculus, but we have this x squared, which complicates things. So I'm going to call this g of t. So g of t 1 plus t cubed. And there's a shortcut to this. Basically, you just evaluate it at the upper bound times the derivative of the upper bound, subtracting it evaluated at the lower bound times the derivative of the lower bound, but I'll show why that's the case. This is like what I like to do. So we know that f of x equals the integral from x to x squared of 1 plus t cubed. We know that this whole part is just g of t. So when we integrate this, we'll get the antiderivative of g, which I'll just call big G. So we have big G of x squared, because that's the upper bound, minus big G at x. And so now, if we take the derivative of f, big F, we have f prime of x equals g prime, which is just g, small g, of x squared, times the derivative of the inside by the chain rule, which is just 2x, minus the derivative of g, which is just small g, evaluated at x, times the derivative of x, which is just 1. So g of x squared is just square root of, I'll put the 2x out front, 2x times the square root of 1 plus x squared cubed minus 1 plus x cubed. And so now this is just 2x times square root of 1 plus x to the power of 6 minus 1 plus x cubed. And then f prime at 4 is what we want to find. So that's just 2 times 4, square root of 1 plus 4 to the power of 6 minus square root of 1 plus 4 to the power of 3. And so this is just 8 times 4 to the power of 6 is 4,096 plus 1 is 4,097 minus square root of 1 plus 4 cubed. 4 cubed is just 64. This is 65. So this is the answer. 8 times the square root of 4,097 minus the square root of 65. And so now I'll go on to the next question. I just noticed that I missed someone's question. I missed Faison's question. He said that could you go over different substitutions for infinity, like infinity over 0, infinity over infinity, and e to the infinity. So I'm assuming you mean like indeterminate forms and everything. So yeah, I'll just quickly go over that. If you have the limit as x goes to infinity of a function f of x or f of x over g of x, Let's say that the limit as x goes to infinity of f of x equals infinity, and the limit as x goes to infinity of g of x goes to infinity. So this will just be infinity over infinity, which is an indeterminate form. And to do this, to solve this, we would have to take the derivative of both the top and bottom, and then we can evaluate at that. And that's just L'Hopital's rule. And there's some other indeterminate forms, like you could also have, you could have 0 over 0. You could have infinity times 0. Infinity times 0. And with this one, you just divide by the reciprocal of one of the factors. And then that will give you either infinity over infinity or a 0 over 0 indeterminate form where you can use L'Hopital's rule. You could also have 1 to the power of infinity. And for this one, there's also infinity to the power of 0. You would take the natural log of both sides, like you would say that y equals the inside, and then you would take the natural log of y and then the natural log of the inside. And since the natural log is a continuous function, the natural log of the limit will be the limit of the natural log. So you just have that's equal to the natural log of the inside, and with the natural log properties, you can take the exponent down, and you'll get an infinity times 0, or a 0 times infinity indeterminate form. And then you can just use this trick on it, where you divide by the reciprocal of 1, and then use L'Hopital's rule. And then I saw you mention there e to the infinity. E to the infinity is just infinity, because e is just like 2.718. It's a positive number. So if you multiply it by itself an infinite amount of times, it's going to blow up to infinity. So now I'll go on to the next question. So it says let g of x equal the integral from -1 to x of t plus 2 dt, where x is greater than -1. Catch the area represented by g of x. Okay, so the area represented by g of x. So we know that we have the graph of x plus 2, or t plus 2 in this case. We can call that t, and we can call that y. We know that it'll intersect the y-axis at 2. It goes like that. So we want to find that on the graph. So this first one, no, because that isn't the shape of a line. Same with this one, and same with this one. So we're only interested in C and D. And we want to go from -1 to a value x. And then g of x is this area. And so as you can see, that is C. So I'll move on to the next question now. Okay, so it says find the limit as x approaches 0 from the right of 1 minus 2x to the power of 1 over x. So if we just took this limit, we would see that the inside goes to 1, since 2 times x is just 0, and then 1 minus 0 is just 1, so that goes to 1. And then if you're going from the right of 1 over x, you can imagine 1 over x like this. As you're going to 0 from the right, which is here, it goes to positive infinity. Or you can just think about it like algebraically. If you're dividing by a really small positive number, you're going to go to infinity. I just saw a question. Wouldn't the area question be D because it intersects the t-axis at -2? Oh yeah, true. For some reason I thought that that it would intersect before -1, but yeah, you're right. So it would be D. Sorry about that. So it would be D because it intersects at -2, so the graph will look something more like this. Or that's 2, that's -2, and then -1 will be somewhere in there. And you want to find this area where you have X there. So yeah, it would be D. Now for this one, this is 1 to the power of positive infinity, and that's an indeterminate form. So I'll use what I said right here. We want to say that y equals 1 minus 2x power 1 over x. And then we can take the natural log. So ln y equals ln of 1 minus 2x to the power of 1 over x. By log properties, this is just equal to 1 over x times ln of 1 minus 2x. By the way, it's 7 o'clock now, but I can go for a little longer. So this is what we have right now. If we take the limit of both sides, so the limit as x goes to infinity of ln y equals the limit as x goes to infinity of 1 over x is ln of minus 2x. And then from here, this is just a 0 times, should be 0 times, sorry, negative infinity. Oh, wait a second. Sorry, just give me a sec. Oh, it's 0. Sorry, I thought it was infinity. 0 from the right of 1 over x, which goes to infinity. And then ln of 1 minus 2 times 0 is just 0. So I just got a question. Will the OneNote be posted? So not the OneNote file itself, but yeah, I can take screenshots and then post it into this channel. There'll be a lot of screenshots, but yeah, I can do that. So this will be infinity times 0. So that's an indeterminate form. So we can do the little trick where we flip one. In this scenario, it's easy. Oh, it's not infinity, it's 0. 0 plus ln of 1 minus 2x over x. Because this was already here. So this goes to 0 over 0. Since ln of 1 is 0, and then obviously x is 0. So this goes to 0 over 0, and we can take the derivative of both the top and bottom with L'Hopital's rule. This is the limit as x goes to 0 from the right of the derivative of the top, which is 1 over 1 minus 2x times the derivative, which is just -2, over the derivative of the bottom, which is 1. So we have the limit as x goes to 0 from the right of -2 over 1 minus 2x. And then that's equal to ln of y. And so here, the denominator will go to 1 because the 2x will vanish. So this entire thing is equal to -2 over 1, which is just -2. So that's ln of y. So that means that y equals e to -2. Hopefully I didn't make a mistake there, but that should be good. Yeah, should be good. Or you could write this as 1 over e squared if you want. There's another question. I'll do this one. It says evaluate the following limit. how to get rid of the ln. If you have ln of f of x equals g of x, you can imagine this as doing e on both sides, and then the e and ln will cancel, and you get that f of x equals e to the g of x. So in this case, f of x is just y, and then g of x is -2. So yeah, no, the one before that. I think you might be. Are you referring to right here? It's just because I took the derivative of the top and the bottom. So the derivative of natural log of 1 minus 2x is -2 over 1 minus 2x. So hopefully that makes sense. Yeah, because we just used L'Hopital's rule there. Because we had a 0 over 0 indeterminate form, so we could use L'Hopital's rule there. So this next one says evaluate the following limit. The limit of the sum going from I equals 1 to n, or the limit as n goes to infinity of the sum going from I equals 1 to n of 1 over n times 1 over n to the power 4 minus 1. So, I mean, I don't know, we could evaluate this like rigorously, but the thing is we know now that this is just equal to the integral of a function. The thing is we don't know the bounds. So, because I'm trying to think of how to do this. We have an I to the 4th. Could you do b equals 1 and a equals 0? Yeah, we could do random bounds. Yeah, because there will be multiple functions that satisfy this over different intervals. So yeah, we can try that. We can say that a equals 0 and b equals 1. So we know that delta x equals b minus a over n. And so we can just make sure that checks out. That's 1 over n. And yeah, that's good. And then xi is a plus I delta x, which is just I over n, which checks out here as well. Because we have our delta x right here, and we have our xi right there. So this will just be equal to, so no, if we have the limit as n goes to infinity of the sum, the sum from I going to 1 to n of 1 over n, or I'll call this f of xi delta x. This is just the integral going from a to b of f of x dx. So now we'll transform this big thing into an integral. So you know that we have the limit as n goes to infinity of the sum going from I equals 1 to n of 1 over n times I over n to the power 4 minus 1. Now, we know this is delta x. You know, this inside is f of x at I. So, we know what xi is I over n. So, if f of xi equals I over n to the power 4 minus 1, and this is xi, we know that f of x equals x to the power 4 minus 1. So, this is just going to be the integral from 0 to 1 of f of xi, which is x to the 4th minus 1, dx. I don't think any other a or b would work, as there be an a plus a term on the inside. Yeah, that's true, actually. Yeah, so 0 and 1 would only work. So this is the integral from 0 to 1 of x to the power 4 x to the power 4 minus 1. And then this is just 1/5 x to the power 5 minus x. That's evaluated from 0 to 1. So this is just 1/5, is 1 to the power 5 minus 1, minus 1/5, 0 to the power 5 plus 0. These are both just 0 right here. And then we have 1/5 minus 1, and 1 is just 5/5. So this is negative 4/5. So the answer is B. So I don't see any other questions in chat. So I'll wait a couple of minutes just to see if there's any other questions, and then if not, I'll head off. Would this trick work for any problem like this? Well, it should if you have a Riemann sum. Keep in mind, this is only for Riemann sums, where you have the limit as n approaches infinity of sum going from I equals 1 to n of something that's of the form f of xi times delta x. It would work for anything like this. I can't think of a scenario right now where it wouldn't work. And from now on, we won't even really be seeing this anymore because it's like derivatives with first principles. After we learned first principles, we never looked at it again because we just had a smoother way of doing it, which in this case is the integral. So this should work in all cases. So I saw a question saying, how did you find the bound again? Well, I know that delta x is 1 over n, and I also know that delta x is b minus a over n. And the simplest, like if we want to get I over n, we know that a has to be 0, right? Which someone pointed out in chat, which I didn't realize before. A has to be 0 because we have I over n. We don't have 1 plus I over n or 2 plus I over n. We just have 0 plus I over n. So we know that a has to be 0. So we have that b over n equals 1 over n. That means that b has to be 1. So we know that this is the integral from 0 to 1. And then someone asked, are you going to upload the OneNote file after? The thing is, I won't upload the actual file, but I'll upload some screenshots. If I can find a way to upload the actual file, I'll do that. But if not, I'll just upload some screenshots. Another question says, if we tried to solve it by solving the summation and then taking the limit, we would need to know the summation of I to the 4, right? Yeah, so I'm pretty sure this question was actually built for you to go to the integral because we don't know the sum of I to the 4th. Because we would have the sum of I to the 4th over n to the 5th minus the sum of 1 over n. We can find the sum of 1 over n, but we can't find the sum, at least within the scope of our course, of I to the power 4. And then, would there be any case where we probably have to calculate it explicitly? Like I just said, we wouldn't have to calculate this one because we have an I to the 4th. If this is like an I to the 3 or an I to the 2 or I to the power of 1, we could because we have formulas for them. But we don't, in this course, we don't have a formula for I to the 4th. So it wouldn't be the sum of I squared squared because some people think that it would be like the sum of I squared and then the sum of I squared, but it doesn't work like that because I squared squared is just still I to the power 4th, and you can't really like exponentiate the summation. Like it's kind of hard to explain, but yeah. Yeah, like as Hakeem said, it's not the same. But yeah, I'll wait for a couple more minutes, just if there's any more questions in chat. But if not, maybe by 7:18, if there's no more questions, I'll just head out. By the way, I'm sorry for all the mistakes in this one. That one question was killing me, and this question too. But it's fine because we got the right answers in the end. You go back to the berries. Sorry, I don't. Oh, the berries. Yeah. this question. I would zoom out more, but that would just make it really small. So we got 25.6. Once again, I don't know if that's right because this was a long question. So it could be wrong because I didn't look over this again. I just went through it once. The answer isn't in the MC. Oh yeah, I didn't even see the multiple choice. Swapped x and 30 minus x. It should still be good because I have x here and then this is x. I could have called this x, but this would just turn into 30 minus x. It doesn't matter which one we choose, just in the end, if I picked x here, x would give me this distance, whereas x gives me this distance with this method, but it seems like I might be wrong. I could check over this question again, just to see where I went wrong. Are we expected to only know integrals of polynomials, or there's anything fair game? So probably for this, we should know like integrals of polynomials, obviously, like with the power rule. We'll want to know like trig integrals, like that the integral of sine is negative cosine, the integral of cosine is negative sine. And then we also want to know some like the inverse trig function integrals, like how the integral of 1 over 1 plus x squared is inverse tangent. The integral of 1 over square root of 1 minus x squared is inverse cosine, or inverse sine, I mean. If anyone else has any other like integrals that we need to know, drop them in the chat. I can't really think of anything else right now. Obviously, exponentials like e to the x. If you have, this comes up, I'll write this down as well. If you have the integral of a function a to the power of x, the integral of this will be a to the power of x over the natural log of a. That's another useful one. Oh, right. So yeah, I got the right answer. I just forgot to I got the right answer, but I was looking at this distance, x right here. But the question's asking for this distance. So yeah, the correct distance, let's call it d, is 30 minus x, which is 4.4 meters. So yeah, thanks for calling that out. So we still did get the right answer. It's just I measured the wrong distance. Which yeah, as you guys said, that's d. I'm trying to think of any other integrals we'll need to know. But yeah, the only like integration methods we'll need are just like remembering antiderivatives, and then like last lesson we did u sub. So is there anything else you guys want me to go over? Yeah, go ahead. Do you have any advice on how to find the equations for optimization problems, i.e. the 3D ones? So, I'm assuming you mean like 3D box ones or something. Those ones where you want to find like the maximum surface area or the maximum volume or like minimizing cost. It really just comes down to like seeing what the question's asking. Like if the question's asking for cost and then it gives you how much like each side costs per meter squared or whatever, or per centimeter squared, the cost will be the cost will just be how much each side costs times the area. So that'll be the total cost. Then you want to find an equation for that based off like the side lengths, which could be x squared if it's like a square base or something. And then the other side lengths with their costs, and then you just want to set that the derivative equal to 0. And yeah, I'll post screenshots to OneNote. And then found this on the textbook. I don't know, maybe worth covering. Write the sum in an expanded form of -1 to the power of j, going from j equals 0 to n equals 1. So I'll do that. So we have the sum going from j equals 0, n minus 1, of -1 to the power of j. So this will be -1 to the power of 0 plus -1 to the power of 1 plus -1 to the power of 2 plus -1 to the power of 3 plus ... plus -1 to the power of n minus 1, or I'll do n minus 2 plus -1 to the power of n minus 1. So first few terms we have 1 minus 1 plus 1 minus 1, and then here if we have like, I'll choose this for an example. If we have -1 to the power of n minus 2, oh, never mind. I was gonna say that we could do something with this, but no, we can't. You can only do something with this if it's like -1 to the power of 2n, because that's always gonna be even. So that'll just be 1. But I don't know if they want us to like find somebody to evaluate this or just write this like I did in the first line. But this would be -1 to the power of n minus 2. Oh, well, I guess this is the same as -1 to the power of n. And then this is... Oh, okay. Because if we have -1 to the power of n minus 2, that's the same as -1 to the n times -1 to the -2, -1 to the n over -1 squared, which is just -1 to the n. If we have -1 to the power of n minus 1, that's the same thing as -1 to the n times -1 to the -1, which is -1 to the n over -1, which is just -1 to the n. So this is actually -1 to the n. Those cancel. And it seems like this entire thing should cancel. But I know that it shouldn't cancel because I know that this sum shouldn't be 0. So I'm pretty sure this sum will have... I was gonna say the sum will have no answer, but... Actually, no. I'm thinking of this sum going from 0 to infinity. This is going to a finite number, so I think this actually might just be 0. Because if you like pair everything up... Actually, no. It shouldn't be 0. Because if n is odd, for example... yeah, exactly. It depends on parity. If n's odd, then n minus 1 will be even, and then in that case, everything will cancel out. But if n is even, then n minus 1 will be odd, and then not everything will cancel, and you'll either be left with a 1 or a -1. So this could be -1, 0, or 1. It just depends on the case. Oh, right, yeah, it can't be -1. So it's just 0 or 1. And then find the antiderivative of this. Okay, so this would be really easy if the x squared was inside of the square root, and then we had an x outside because we could just do u sub. But I still may be able to do u sub. If I say that u equals x squared, du equals 2x dx, and we can this makes this tough actually. I was gonna say we could do x equals square root of u, but that's only when it's positive. Hakeem, where did you find this? Trying to know if it's like textbook problem sampler. Thing is, if we do u sub with x plus 2, we'll just get that du equals dx, and we'll go nowhere. Oh, wait. Oh, yeah. See, I completely overlooked that because du would just be dx, but if we do u equals x plus 2, then we know x equals u minus 2. So x squared equals u minus 2 squared. And we know that du is equal to dx. So this will be the integral of u minus 2 squared times square root of u, integrated with respect to u. And then this is just u to the power of integral of u to the power of 1/2 times u squared minus 4u plus 4 equals u squared, that's just u to the power of 4/2. So this is u to the power of 5/2 minus 4u to the power of 3/2 plus 4u to the power of 1/2 integrated with respect to u. And then if we integrate this, add 1 to the power, get that u 7/2 divide by the power, which is 2/7, minus 4, leave a space there, 5/2 times 2/5 plus 4, leave a space again, u to the 3/2 times 2/3, and plus c. And we know that u is just x plus 2, so this is 2/7, x plus 2 to the 7/2 minus, I can do 8/2, x plus 2 to the power of 5/2 plus 8/3, x plus 2 to the power of 3/2 plus c. So that should be the answer. Let me know if anyone else has any more questions. Yeah, no problem. I'll stay in here until like 7:33 to see if anyone has more questions, but oh, there's another question. So I think this is going to be the last question. So the function f of x is continuous on the closed interval 2 to 5 and differentiable on the open interval 2 to 5. Furthermore, the derivative is bounded such that the absolute value of f prime of x is less than or equal to 1 over x. Using the mean value theorem, what can we conclude about f of 5 minus f of 2? Okay. So, the absolute value of the derivative can't exceed 1 over x. So, like the average, if we do, I'll call this m, the average slope over the interval, that'll be f of 5 minus f of 2 over 5 minus 2, which is just 3. And we know that the absolute value of this will be 1 over x. So this is the absolute value of f of 2 minus f of 5 over the absolute value of 3, which is 3. So this is less than 3 over x. And then from here, I'm just seeing where we should go next. Well, I see that we have the endpoints 2 and 5, so I know we can do something with those. I'm just thinking about where we should go. Well, okay, so okay, I think I know where we go from here. So f of 5 minus f of 2, that should be greater than 3 over 5 and then less than or equal to 3 over 2, which is 0.6 is less than or equal to f of 5 minus f of 2. It's less than or equal to 1.5. So I think this should be the right answer. Correct me if I'm wrong. Currently it's negative 1.5 and oh yeah, since this is the absolute value, yeah, it should be, yeah, okay. It's because since 3 over 2 is greater than 3 over 5, we want to maximize 3 over x to see what the biggest f of 5 minus f of 2 can be, but this is the absolute value of f of 5 minus f of 2. So if we had a number in here, like let's say negative 1, this will just become positive 1. So we want to make sure that it's the largest region possible. So we have f of 5 minus f of 2 is less than or equal to 1.5, greater than or equal to negative 1.5. So it should be C. Because this whole thing, we can just plug in x equals 2. Because if we plugged in x equals 5, because if we plugged in x equals 5, it would be a lot smaller than x equals 2, because 3 over 5 is 0.6, and then 3 over 2 is 1.5. So we want to maximize this because we want to find the range of f of 5 minus f of 2. Yeah, exactly. Here, I'll try to write this out more clearly. The absolute value of f of 5 minus f of 2 is less than or equal to 3 over 2. but this means that f of 5, if we take away the absolute values, 3 over 2 is just 1.5, so should be 1.5 on either side, because if this entire thing is less than 3 over 2, then if we take away the absolute values, then we need to constrain it within that. So are there any more questions? Yeah, I can see how that one's definitely tough. It could throw you off. Like, it threw me off with the 3 over 5 thing. But you just want to remember that 3 over 5 is less than 3 over 2, and you're trying to maximize it because you're trying to find the range it's within. Since you know that's the interval is 2 and 5, and it must be less than 1 over x, 1 over 2 is bigger than 1 over 5, so you choose that. Yeah, that too. So yeah, once again, I'll wait a couple more minutes for any more questions, but I think if there's another question, that'll be the last one. So I don't think there's any more questions, so I think I'm going to end the session here. Hopefully you guys took something out of this, and hope you learned something. I know I made a lot of mistakes with some of the questions, but once again, I'm a first year like you guys. I'm in the exact same program, so I just made some mistakes, but it's fun because thank you guys for correcting me on all those mistakes. But yeah, I haven't done the problem sample or anything yet, so that's why. Yeah, for anyone saying thank you, yeah, no problem. It's my pleasure.